Well, some functions are increasing or decreasing over their entire domain. Many others are not. A value of input where a function changes from increasing to decreasing as we go from left to right, that is, as the input variable increases, is called a local maximum. So it's going from increasing to decreasing as we go from left to right. That's the idea there. Okay, if a function has more than one, we say that it has local maxima. So we call it a local maximum if it's one, local maxima if it's more than one. Similarly, a value of input where a function changes from decreasing to increasing as the input variables increase is called a local minimum. And if it's more than one, local minima. Together, local maxima and minima are called local extrema. So if the problem says, hey, find all local extrema, that means both maximum and minimum. Or local extreme values. That's another way to say the same thing of a function. Okay, the singular form of is an extremum. So if I just have one, it's an extremum. Or if I have multiple, it's called local extrema. Okay, often the term local is replaced by the term relative. In this text, we will use the term local. Okay, so we don't have to worry about relative here, but some books do say relative. We're going to use the term local in this book. Okay, so anyways, take a look below here. It says use the graph of the function to find, and this says local minimum. It might say minimum. Maybe I should say that as well. This is my wording, so I could have said it a little better there, I guess. But we're looking for all local minimum, or maxima. Excuse me, that's maxima. Okay, so first things first. Again, we're looking, if it's a maximum, we're looking where it's increasing to decreasing. Okay, so when I look at these values here, where is it going from increasing to decreasing? So it's increasing here, and it's decreasing here. So that would be a point there where it would go from increasing to decreasing. So I would say that that's -7 for the x and 5 for the y. So this would be -7, 5. And that's where it's going from increasing to decreasing. Now when I look at this value here, that's not going from increasing to decreasing. This value here is not going from increasing to decreasing, but this value here is going from increasing to decreasing. So that would also be a local maximum. And that is the values, that would be 4, 8. And those would be the only two where I see it going from increasing to decreasing. Now let's talk about local minima or local minimum. Okay, so that, if you look at the local minimum, that says I'm going from decreasing to increasing. So I'm going to go from decreasing to increasing. So I have to be going down first. So it's going down here. I looked here, it's going down, but there's no other side to go up. So that's why I kind of left that one alone. It's got to go from down to up. So decreasing to increasing. So it's decreasing there and it's increasing there. So that's where it's decreasing to increasing. So I would say there's going to be a value of, that's a local minimum. Okay, so that's going to be 1 and 3 there. So I would say 1, 3. Now I'm writing ordered pairs here, so keep that in mind too. And then we also have one here. It's decreasing there and it's increasing there. So at this value, that would also be 1. So I'll call that 8.5. And that looks like on the y value that that's going to be 4. So that would be 8.54. Hopefully that's okay. These really aren't too bad to do just by looking at the increasing or decreasing or decreasing to increasing. That's all I'm looking for with these. So anywhere I got that change of direction, I'm going to have a local max or a local min. That's it.